Hey-oh, 27. All right, I know what you're thinking. Double rainbows all the way. Distributive property. So when you are doing the distributive property, you're multiplying. So square root of 3 times square root of 12 is square root of 36. Our same rules still apply. You multiply radicals with radicals, regular numbers with regular numbers. On that second rainbow, you can kind of pretend there's a 1 there. You have 1 square root of 3 times 5 square root of 5. 1 times 5 is 5. Square root of 5 times square root of 3 is square root of 15. But wait, there's more. Hopefully your eyes got big when you were looking at the square root of 36. You say, well, Mr. Lordson, that's just 6 plus 5 square root of 15. Don't even think about combining those two together. You got a Montague over there, you got a Capulet over there. Keep them separate, otherwise bad things happen. 28. Distributive property. Square root of 5 times square root of 20 gives me square root of 100. Plus numbers with numbers. Okay, that's basically 2. Radicals with radicals. Square root of 35. Oh, this problem is so 100. Get it? Never mind. Square root of 100 is 10 plus 2. Can I break down 35? There's no perfect squares that go into it. So no, this is it. 29. Oh, buckets. You're dealing with double distributive property, or also known as FOIL here. So you're going to have to do first times first, outside times outside, then you're going to have to do this times this for the inside, and this times this for the last. So let's talk about this first rainbow, 8 square root of 2 times 8 square root of 2. Numbers with numbers. 8 and 8 gives you 64. Square root of 2 times square root of 2 gives you square root of 4. Second rainbow. Numbers with numbers. Looks like it's just 8 times negative 1, basically. Radicals with radicals, so that's radical 14. Inside, numbers with numbers, 8 times 1, so positive 8. Radicals with radicals, so that gives you square root of 14. And then lastly, you have square root of 7 times negative square root of 7. So it's going to be negative, and that's square root of 49. Then what we're looking at here is 4 terms. These two guys, 8 square root of 14, negative 8 square root of 14, they gone. They cancel each other out. Over here you got, okay, square root of 4 is 2. 64 times 2 is 128. Over here you got square root of 49, or minus square root of 49, which is just 7. 128 minus 7 is 121. 30 is similar, so it might be a good challenge to try that on your own, hit pause, and see if we get the same thing. And here we go. 4 root 2 times 4 root 3 gives you 16 root 6. Second rainbow, negative, numbers with numbers, 4, radicals with radicals, 12. Inside, so this guy, you might be doing the box method now too, that's fine, but you get positive 4 square root of 18. And then lastly, you get, let's see, negative square root of 6 times square root of 6 is negative square root of 36. Oh, I don't have anything right away that I can combine. Now I do know that the square root of 36 is just 6. I can make that minus 6. I can break down radical 18. Let's go into the problem. Okay, sorry. So I can write small here. This is square root of 9 and square root of 2, which is just 3, square root of 2. But there's already a 4 there. So what happens is I'll end up just being 12 square root of 2. And then over shear, let's get a little zoomage. Dealing with negative 4 square root of 12. Square root of 4, square root of 3. It's 2 square root of 3, but I have to include the negative 4 there. So what I'm dealing with is negative 8 square root of 3. 16 root 6 can't break down any. So this, ladies and gentlemen, is your answer. Because you can't combine any of these things because they're not like. Isn't that crazy? Just leave it as is. Nice, ugly, weird answer.